Time we on? 1 minute past. Let's give it 1 more minute for any stragglers. Hello, Raw. How are you doing?
Hello. I am well, thank you. How are you?
Good, good,
Still
good.
abroad?
Very good. Still abroad. Still abroad. You may hear how abroad I am at some moment. I've got a house next to a mosque, so it's been prayer time quite regularly on my calls for the last little while. So you never know. Well, actually, I don't think it is prayer time now, but maybe
Makes
later.
us travel a bit. Virtual traveling, that is. Just listening to that.
Yes. 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 No, it's been. I've been enjoying my life as an accidental digital nomad. It's hasn't been so bad. I can't complain. Now let's see. Panelists and attendees.
Should I perhaps share my screen?
Yes, you want to just check what?
I'm going to have a go.
You can. If not, I can share it for you.
Thank you. I'm not really used to use Zoom, but it seems to be pretty much the same, isn't it? Can you see my screen right now?
Yeah, I can. Yeah, you probably want to put it onto present mode though, because currently we can see. Yeah.
Great.
Great.
That's working fine. Fantastic.
Cool. Well, Teresa, are we on record?
Yes.
Excellent. Excellent. All right. Well, why don't we begin then? So, for anyone who's just come in the last couple of minutes, welcome. This is the first talk on our expert stage here at our decarbonisation hack from home. As I mentioned in some of the other sessions that we've had, DataSwift is a deep tech company, a university spin-out based on academic research from universities of Warwick and Cambridge. As a result, research, learning, academia, spreading ideas and inspiring people with those ideas is central to our mission as the company. And so really manifesting that in the program that we put on the expert stage. So alongside your hackathon content, you also have this other stage designed to help you as you form your ideas, both at this event and in your lives afterwards. So we've got an exciting roster of speakers come to tell you a little bit more about interesting trends in the world of data and energy. And without any further ado, I would like to welcome our very first speaker from UEL, Dr. Aurore Julian, who's going to be speaking, as you can see here, on driving decarbonisation of smart meters. Aurore, over to you. Thank you very much for joining.
Thank you, James. Thank you very much. So yeah, this is so I'll introduce myself first. So my name is Aurore Julian. I come from the building industry, actually, from background. I used to work on designing low carbon buildings for many years before I joined university. And now I'm a research manager for the Eastern New Energy Project. You can Google us and find out more about this if you like. This talk is effectively a lecture which is shrunk into 15 minutes. So I'm going to have to speak quickly, and I've tried to reduce it's always a dangerous thing to do that. I've tried to reduce my slides to something that is possible in 15 minutes. So it's about driving decarbonization or lowering energy consumption with smart meters. It's more or less focused on domestic households, really. But many principles can apply to other situations as well. So energy consumption is driven by many factors. Economic factors is a very important factor, so how much money we have, and how much money energy costs. Structural factors, it's going to be about for example, the building energy efficiency, where it's located, who owns it, and how big it is. Social factors, so this is about what is normal and also the meaning of using energy. And this is a very important factor, and also what our neighbors are doing. So that's a very important factor when we look at energy consumption. Everyday practices. So this is the kind of thing that we are used to do, and that also affects our energy consumption. So for example, we normally now wash our clothes very frequently. In the past, we didn't wash our clothes so frequently. That is the normality. And this is the habit we have. So that's also important. And finally, the environmental values, which surprisingly are not a very major factor compared to, for example, economic factors. So how wealthy we are tends to be more important than how much we believe that we should save energy in a household. So I think this is something to keep in mind when we thinking about energy consumption. This is the product of a little bit of research I did a few years ago as part of my PhD. So it's a little bit old, but generally these principles are of course still valid. Now I was looking at the energy savings from various actions in the homes. You know, if we were to change something in our life, how much energy would be saved through that specific action? And you know, there's some kind of quite extreme actions that I've taken here, you know, as an example. Like, for example, heating only one room in your house would be quite an extreme thing to do to try and save energy. But it's just for, you know, for us to have a comparison point. And if you look at these data here, what it looks like is that in the UK, so this is specifically for the UK, energy saving actions which concentrate on reducing energy use from heating. So these are just one-offs, what we do in our daily life. So it's not about insulation, right? So all of these actions that relate to heating tend to save the most amount of energy. And in addition, things like, for example, unplugging the phone charger almost doesn't have any impact comparably. Or just reducing how much water, and I would still encourage you to do that, obviously, but reducing the amount of water in the kettle, in fact, doesn't really have that much impact. This suggests to us that perhaps if we were to try and use maybe smart meters in the context of trying to save energy, we'd have to consider what are the most effective way to save carbon and energy within a household in this case. So I think we really need to focus on those actions that are more effective. Now, an issue with energy is that people tend to not really understand their energy consumption. They don't understand how these activities, these daily activities, relate to their energy consumption and how much it costs. And in fact, many people, about a third in the UK, think they just don't really understand their energy bills at all. And you know, smart meters could help in that context. But there are problems. Energy use really relates to habit or behavior, as I said earlier. And in addition, energy consumption is not really financially driven. So we didn't need to think about how we can motivate these people, not necessarily just through financial means, through other things. So it's not just about money. And we look at other control systems that we have in the home. For example, the thermostat. 20% people in the UK do not actually know how the setting of their thermostat, you know, what it does and what the setting is in their home. And in fact, even some people in the UK do not have a thermostat, quite surprisingly. And so we also need to understand why it is that people are not, you know, always using those systems. You know, perhaps they need to be made easier to use. And also perhaps we need to take into account that people might not be that interested in some cases. This is why they might be ignoring those systems. And another issue that we need to consider when it comes to energy consumption is what it is that people are going to do with whatever is left, you know, from their, from their energy savings. So maybe we're going to save money, and maybe that's going to get us to use energy in a different way. So it's very often the example that's given is that if we are going to save money through a more energy efficient car, we might decide to take planes. And that will result in further energy consumption and also in further carbon emissions. So we need to think about the system as a whole. Within a home, this is particularly prominent when we're considering lighting. What researchers found, and perhaps you can also associate to this yourself, even me, with all this knowledge I have about this stuff, I still do it as well. What can happen is that we have energy efficient lighting, and because we know that we are saving money through this energy efficient lighting, we're just going to leave more lights on. And also, in fact, we often do change the way we light our homes, and we're seeing the development through homes of more complex lighting systems with mood lighting and more light bulbs effectively, and more lighting, which is going to improve our comfort. And this kind of approach is seen in many different ways. So this rebound effect. It's also seen within homes in terms of the heating and how we like to control our heating systems inside homes. So over the last 20 years, we have seen improvement in the insulation of homes. And in the past, people used to have their bedrooms a little bit colder. So people would switch off sometimes the heating in the bedrooms, or, twiggle the TRVs to have less heating in the bedroom. But people really like to have really warm living areas in comparison. And with the improvement of insulation, it's found that there can be a trend where people want to have a warmer home overall. And so they will want to have a warmer home, but also they want all their rooms to be warmer. So we want to be more comfortable. And of course, because we're paying for that comfort, we feel justified that this is okay. Another way this can be experienced is through the impact of technology. So our technological items like washing machines are becoming more and more energy efficient. And sometimes we also learn through our practices, we learn ways to use less energy. For example, by washing our clothes at 30 degrees instead of, say, 16, the way it was done in the past. So the washing machine energy use in the UK is dropping, but at the same time, the total energy use of the washing activity is still going up, as you can see in the line above at the top here. And the reason why this is happening is because in parallel to this lower energy use of washing machine, we are using more and more tumble dryers. So people are not really motivated by the cost of the tumble dryers. It's quite costly to run a tumble dryer. They're thinking about convenience. And this is happening throughout. So, one of the main things that we are scared of in terms of energy consumption for buildings is the use of air conditioning, which is going up and up and up and up. And if we have more efficient homes, of course, this is going to improve how much energy we overall. Perhaps the impact will be still quite high in terms of energy use. Now, on a more positive note, I will talk to you about something called the door hanger experiment. So this is a piece of research in the States where door hangers were hung on people's doors, and on the door hangers, there was various types of messages encouraging people to save energy. The first door hanger said something like, this is how you can save energy. So this was in California during a hot time. And this is how you save energy. You need to use a fan instead of switching on your air conditioning. Another door hanger, different type, had on it, be a good citizen, be a good American by saving energy, and explain how you could do that. And then there was a door hanger which encouraged people to save the planet, talked about climate change and carbon emissions. A fourth door hanger encouraged people to save money and explain how much money could be saved through energy saving actions. And finally, the final door hanger just told people that in average, most people in this area weren't using air conditioning, but they were using a fan instead. And this was, I don't even know whether this was actually true within the study, but this was the message that was on the door hanger. And
this is very interesting. I'm dying to know which one it was.
Which one do you think it is?
I would hope that it was, I feel my guess is save the planet is too general. Save the money is obvious, but it wouldn't be. I'd hope it would be a good citizen.
It's
but I
your
believe
neighbors are doing better.
Yes.
So yeah. It is social influence. So we want to be like our neighbors, basically. We want to be a part of society. We want to be part of a group, a social group. And so this last door hanger was the most efficient of all of these, in getting people to save energy, was the most effective of all of these door hangers. And so this really raises the questions, what actually works? And, I think also perhaps you can, think within yourselves. If I was to design a system that, harvests the use of this information from the smart meters, how could you harvest this particular way people think to get them to save energy? I think this gives opportunity from that point of view. And generally, so this is quite a general slide, but it's just a sort of overall idea of what works in terms of energy saving. Social influence tends to work better than information, as we've just seen. People work better with goal settings than with general "you must save energy" messages. People prefer to save energy rather than money because they feel entitled to the money they spend. We need to have concrete opportunities for change, not just information saying, oh, we're all going to die because climate change. We need opportunities, specific opportunities to change specific things, and that works also better. Empowerment is better than blame, obviously. And finally, load shifting is also a very good way to save energy by using energy only when it's available and the greenest energy is available. That's a very good way to get people to save energy without them even noticing potentially using automation. So for example, we have loads of energy from wind turbines. That's a good time to be using this electricity rather than whatever coal stations could be on if we had a really peak use. So coming back, I'm aware that I'm a little bit late. I'm sorry, I just tried to run through quickly. Coming back to the smart meters. So smart meters give us really detailed information about our energy use and consequently could give us information about how we could save more energy. And in the UK, people seem to love smart meters. They've been implemented relatively successfully, not as successfully as government intended, but still we have about 40-something% smart meters. Like that was last December in the UK. The main benefits that people can see that's advertised are energy data is available. It's not at the bottom of a basement like it used to be in the past. It can be visible through your phone or a smart a device, a display of some kind that you can have visible in your kitchen. There's no more estimated bills. We can understand the information from the bills because it's provided in a better format. And there's also more options for tariffs to use energy when it's available. Now, how much energy can be saved? Well, the government thought we'd save 2%, but the reality, because of all the things I mentioned earlier, and because of the studies that were done, it was based on people that actually accepted to have the smart meters who might be more inclined to save energy. We don't really know how much direct savings we look at. Another very important point, which is absolutely essential, is that in order to save energy, the smart meters needs to be working with devices that help us to understand how to save energy and harvest, the way people want to save energy, by this sort of, goal setting, for example, or ensuring that it targets through automation those things in the homes that use the most amount of energy. So, and also just not to give people information overload. So it needs to be really simple. Finally, and this is extremely important as well. The smart meters can give way to a more competitive energy market, of course, because we're going to have more detailed information about our energy use and also how supply and demand are the sort of the supply and demand at different times, so that provides opportunities. Also, we can manage peak electricity with smart demand response systems. So for example, smart charging of batteries when energy is more available. And this allows integration of renewable energy like wind, like solar. And also this allows for a more flexible, decentralized energy system. So it's going to enable, for people who have photovoltaics being able to sell it to the grid more flexibly. So there's, these are just examples, but these are other benefits which are not just direct energy savings. And I think that we really need to keep in mind, it's not about just our personal energy use, it's about the grid as a whole and what it enables. And that's it for my talk. Sorry, I overrun by a couple of minutes. I hope that's okay. I've got a bunch of references here that you probably don't want to look at. And that's the end of my talk. Is there any questions?
Well, thank you very much for that. That was really, really interesting. Yes, that was also a very stark graph you showed on heat versus everything else in the British context.
Yeah.
How that had the most
yeah.
emissions.
Well, maybe we'll get better if we have more ground source heat pumps, which are
Yes.
very efficient, and they're being deployed at great speed. So if we have more ground source heat pump and better insulation in our homes, things will definitely change.
Yes.
And so also, if we have more ground source heat pump, that will give us opportunity to use renewable energy, renewable electricity to heat our homes. So this is just based on data which is with gas heating, and
Yeah.
it's also, this information is perhaps now, I would say, 8 years old.
Right.
So yeah.
Well, we have a good talk coming up tomorrow from Professor Martin Freer at the University of Birmingham, talking about the future of heat, which I think will be covering this stuff a lot. Should be pretty good.
Yes, absolutely. I think it's absolutely relevant.
It was very interesting. I mean, again, thank you for that whole talk. It was really thought-provoking. Any teams listening in presently or to recording, I think the lesson on, the slide on kind of lessons about what works and doesn't work is particularly useful. Aurore, could you throw that back up?
Yes, 1 second. I'm just fighting with my...
Make it easier for people to find again. Because all of those are filled with, I think, direct insights for the hackathon projects.
So what works, what doesn't work?
Yes.
Where was it? What worked? I think it was towards the end. This thing?
There it is, yes. Yeah. Are we all right to share this slide deck on the general Slack?
Absolutely, yeah.
Yeah, great. Well, we'll do that so we can go over it again. But I think these lessons here are very useful. Now, I'm mindful of time. I have a lot of questions I want to ask, and only a couple of minutes. But I saw a couple of things. So, you're talking about the proliferation of smart meters in homes in the UK, and I noticed, you showed an app, like a sort of friendly consumer-facing app, gathering in the data from a smart meter. What do you think the role of smart meters will be in British homes in, let's say, 10 years' time? Like, what does the future hold for smart meters, and how they're integrated, how their data is integrated more broadly in the life of the consumer?
I think that actually nobody knows, but I'm hoping that there will be an integration with some of that. Perhaps, first of all, I hope that there will be an integration with smart demand systems that will enable our battery operated systems, like, for example, cars, to use energy when it's available. But it is important that people are still given a certain amount of control, so that they accept these systems. But this is where I'm hoping things are going to go, is that there's going to be a fair amount of automation of our systems, and when the energy is used, in order for us to have a little bit more control on, supply versus demand. I think this is where, to me, this is what is the most important, I believe. But there needs to be some level of control. I don't know how much people are going to be keen to get involved,
Yes.
Perhaps at the beginning, but I don't know in 10 years whether people are going to want to, for the 2% energy saving that they can achieve just through that, as planned, through the use of smart meters. And I think it's not as straightforward as just saving energy. This is the thing, because it's also about when energy is used. If we use energy all at the same time, if we are using energy when sort of, and create peaks of energy demand, inevitably we have these cool stations that might even switch on, or we have at least the gas power stations that are going to be used. And so if we ensure that the peaks of electricity demands are not happening all at the same time, you know, perhaps when people come back from work, I imagine everybody's going to have their sort of electrical cars and plug them in and switch on the heating. You know, the heating is going to be switched on automatically and maybe ramp up a little bit, not very much because we have ground source heat pumps or air source heat pump or whatever. But there's going to be perhaps a peak when people come back from work or before people leave, as there always is. That peak needs to be kept under control, and we need to ensure that we do that in a way which is not just through the use of external batteries. I think just by slightly shuffling things around on how energy is used inside the homes can really help ensuring we're not switching on no gas power stations when we don't need them.
One of our project ideas is currently exploring basically peer-to-peer trading of energy use allocation between households and potentially also within households between devices, precisely for this, you know, demand management use case, which I think is quite interesting.
Yeah, it could very well be that society's mindset is going to really change as well. I don't know. We don't know.
Yes, I suspect an element of automation might be needed for that 2% saving.
Yeah, I think so. But people it might be that it becomes, for whatever policy-driven reason, it becomes, saving energy might become necessary. And so how we do things, our habits and on daily practices might actually change. Our habits of when we see switching things on and how we think about energy might actually change. But that's a very, very slow change. And I don't, until now, things have been going the other way around. For example, you know, I was talking about this thing about using electricity for washing machines. The way we wash our clothes has become very energy intensive because we wash our clothes every day or every couple of days. We don't wear clothes. I mean, I don't know. Individuals vary, obviously, and perhaps with working from homes, people don't wash their clothes as much. Who knows? But we wash our clothes a lot more than we used to. And even if the washing machines are more energy efficient, this is really tempered by this kind of like what is acceptable in society. And so what is acceptable in society is to smell of fresh clothes, but that might change. And things might change because of things which we don't really foresee, like, for example, coronavirus, and working from homes might change how we wash our clothes and how we use energy. So I think I think my point here is that it's very, very complex. It's not just about the technology.
And ultimately, human psychology is central to it.
Yes. And this is why, I mean, when I started looking at energy efficiency, being an engineer from background, I'm an engineer, I was really into technology being more efficient and systems. And then I realized, oh my God, we can't remove the people from this system. And there needs to be some kind of, we need to take into account what people want and need. So we designed these technologies that actually, you know, work for us. And that will include how smart meters are being used. It needs to kind of understand what people want. Yes,
I guess, you know, technology is always embedded within a social system. It's never sort of this free floating artifact sitting on a pedestal. It always has to be enmeshed in what we actually want and why. Interesting. Well, I'd love to chat more on this fascinating set of topics, but we have our another speaker coming in imminently.
Thank you very much.
Thank you very much for your time. If it's all right, you send me the deck earlier. If it's all right with you, I'll spread it on our general channel. You're very welcome to sit in on any of the other talks or come in and mentor some of the hackathon teams if you're so willing. Spread the knowledge and interest in the Eastern New Energy Project. So yes, please do stay with us if you have time over the rest of the day.
Thank you very much. I will pop in and out. I think I have my daughter with me, at the moment, and I've just chucked her in front of the television, which is quite bad. But yeah, I'll come in and out, I guess.
Great.
Thank you very much.